my name is Tommy, and today we're talking about Lewis dot structures. So we have to draw the Lewis dot structures of CO2 and Cn minus. So for CO2, let's first count up the total amount of valence electrons. So carbon has 4 valence electrons, and oxygen, we have 2 of them, times 6 valence electrons. That gives us a total of 16 valence electrons. So then we make our compound with C in the middle, since it's the most electronegative. Go ahead and put in single bonds. So 1, 2, 2 times 2 is 4. So minus 4, and we get 12 valence electrons left. So we can put those all around the oxygens, but we will see that carbon does not get enough valence electrons. So we're going to take 2 from over here, 2 from over here, and create double bonds. And that will perfectly satiate every single atom in that compound. So that is the valence, or is the Lewis dot structure of carbon dioxide. For Cn minus, we just do, well, we count up the electrons. Carbon has 4 and nitrogen has 5, so we have 4 plus 5. And since it has a negative charge, we know that it has another electron since one was added. So that's a total of 10 valence electrons. So we do Cn bonded with N, subtract 2 for that pair, and then we're left with 8. Unfortunately, 8 does not satisfy both atoms. So we can get rid of a pair and turn it into a bond, but carbon is still left without a pair. So we have to get rid of another one from nitrogen and form a triple bond. And that is almost the Lewis dot structure of Cn minus. So all you have to do now is put in that bracket and then -1, and that signifies the Lewis dot structures for cyanide. For this problem, we have to draw the Lewis dot structure for phosphorus pentachloride. So we're going to draw our thing with the least electronegative element in the middle, which in this case is phosphorus, with 5 Cl's going around it. So first glance, it doesn't look possible because phosphorus will just immediately get more than 8. But atoms or elements beyond or at period 3 or beyond are able to occupy more than 8 electrons within themselves. So phosphorus is large enough to have 10 valence electrons occupied. So then we can go about and do our normal duties with Lewis dot structures. So chlorine has 7, and we have 5 chlorines, so that's 35 from chlorine, and phosphorus has 5, so for a total of 40 valence electrons. So we've already have 5 single bonds, so we subtract 10 and we get 30 to distribute. So we have 6 per thing, so I can tell you, since 6 times 5 chlorides is 30, we will have enough dots to fill every single chloride. And that is the Lewis dot structure for phosphorus pentachloride.